So we've currently got class 31, number 31327 in the works department at the moment, and we're currently replacing the old failed parkside control equipment with a brand new Mtronics traction and sound system, along with some other repairs to the locomotive. Hi there, welcome back to the channel, and in particular welcome back to the Class 31 upgrade and repair work series that I'm currently working through. If you recall, if you watched the previous episode, you'll recall that we made up this mandrel on the lathe, and the idea of the mandrel is that it will accommodate the bore in the original wheel, which was on the locomotive, and the axle goes through this hole here. And so I've got a large diameter that fits that, and then I've also got a smaller diameter fits the bore of the new wheel, because the new wheel, the hole is smaller than the old wheel, the old cog wheel. So this spigot here that we've made up aligns the two cog wheels together effectively like that, and now they should be directly over the top of each other. And what I plan to do then, this wheel here, pop that one down a moment. This wheel here is one of the original wheels that came on the locomotive, but on some of the wheels, some of the cogs are worn away because they're only a plastic wheel, and they should be regarded, I suppose, as a consumable item really, because they're only made of plastic and they're running against a steel gear wheel from the motor. And these wheels, these cog wheels, are fastened to the locomotive wheel on the inside face of the wheel, with the axle coming through like that, and they're fastened with 3 bolts through these 3 holes here into screwed holes in the locomotive wheel. So what now I've used this to get the alignment of these 2 wheels correct. What I need to do is to use this old gear wheel as a pilot for drilling the 3 holes in the new gear wheel. And what I've done, before I removed this wheel from the locomotive, I put a Sharpie pen mark on the inside face of this plastic cog wheel, and I also projected that line onto the flange of the wheel, so that I know exactly where this wheel goes with respect to the locomotive wheel, such that these will always line up, these 3 holes will always line up effectively. So that's what I did. I've put a Sharpie mark near to one of these holes so I know whereabouts on the wheel it goes, and I've also marked up inside on the flange of the wheel, such that I know that this part of the cog wheel goes against that part of the drive wheel on the locomotive. And I've also put a Sharpie marker on there, such that when I line these wheels up using my template, I can turn these 2 wheels together, as it were. And what I'm going to do then, I'm going to clamp these 2 wheels together effectively. And what I've done, I've arranged these holes, the way I've set it up, I've arranged for these holes not to interfere with the HPC gears identification label on the wheel, so I don't spoil it effectively. The holes won't drill through it. And then that will line up like that, and then I will clamp the 2 wheels together effectively with a little clamp, like so. and then I'll drill through with this drill, which is slightly oversized of the bolt that goes through the hole, because it's a clearance hole. But this drill is a good fit for the existing hole, so I know I'm using the right drill as per the original build of the locomotive. And I've used my little level box here, set it up level, etc. with this, if I switch it on and then press 0, and then I've gone round and made sure that this isn't this angle here isn't appreciably different from a 90 degrees, as it were. And I've used this level box to check that the jaw is level, and also with respect to the vertical alignment of the drill, as it were. I've gone round with that like that, making sure that it's pretty near within a very close tolerance, really, as close as this drill can probably run to anyway. And then I can utilize the slides on here so that I can drill the holes like that. And I didn't know how grabby this material would be, but it's really not grabby, so it's quite good. And if I didn't have the level box, what I could also do would be to go around with my square, and just make sure that if I were to look down the length of the drill and the square edge of the square, that there isn't any appreciable angle difference. If there's no angle difference, I know I'm fairly good with my leveling. And I know it is because I've been round and had a look with that. And if I wasn't using that, I could always go to a 1-2-3 block and try a 1-2-3 block against the leveling of these jaws and the angle of that drill, as it were. And again, I know that it's appreciably no difference. And we're not drilling through a great length of work anyway. We're only drilling through a very short thickness, about 1/4 of an inch, 6mm. So we'll be fine at that. I generally have a dry run with the drill not running into the hole to make sure it's in the correct location before I actually start the drill running and drilling the hole that I'm aspiring to drill. And there we are, we've got the 3 holes now transferred from this old gear onto the new gear wheel. And with these marks here, we know which of the studs that particular section of this wheel goes on. So there we are now. So I wanted to drill the 3 holes in here before risking making a mess of this centre bore here. If I made a mess of the centre bore there, I didn't want to make a mess of that before actually getting these 3 fixing holes that actually fix this to the back side of the wheel effectively. So that's why I've done it that way. And just to make sure that these didn't have any knocks and dinks on them, etc., I brought the jaws fairly close together before I did the job, and I used a file and just a few swipes up and down with the file to make sure that there were no dinks in here that were going to throw things out of alignment, as it were. So the next thing then is to go back across to the lathe and to try to bore this hole here, which is a 6mm hole, out to this 12.15 hole, I think it was, something like that, 12.15 mil, something like that. So that's the next step. I'll see you at the lathe. Up to it, and then getting the knife and just piercing the tape with the point of the knife. And then again at the other end, I laid the edge of the wheel up against the tape again, and then brought the ruler to the edge of it again, and then just pierced another hole there, and then lined the ruler upon the 2 pierced holes. Like so. And then scored down the tape with a sharp utility or Stanley knife. And then peeled the tape off. And it still had a degree of tackiness to it, stickiness to it. So what I then did, I lay the wheel down, then lay the tape along the side of the wheel, and just rotated the wheel with the tape as close down to the board as I could. So now that should hopefully protect the teeth, which are there, from the chuck jaws hopefully. And if there was an overlap of tape, which on some of the others there was, but this is a curled over piece. On the others there was a slight overlap, and the overlap went between chuck jaws, such that I wasn't being thrown out of alignment by a double piece of tape in one area. If there was no tape at all or an overlap, that then went between chuck jaws as it was gripped in the chuck to be bored out in the centre. So that's the next thing. Now I'll go and take this back to the lathe, and I'll try and bore out this next hole. So here we are then, out at the lathe that I've chosen to try and bore the holes in the new gears out to the size of the hole in the existing gears on the locomotive. Now this lathe, you might call it a cheap Chinese imported lathe, but I'm quite impressed with its accuracy, to be fair. I did try to be somewhat professional and use the 4-jaw chuck that I've got with this lathe. But what I found was, when I was trying to get this bore to run concentrically with the lathe, the gear wheel kept falling forward like that, and I had extreme difficulty, and I spent about 4 hours actually trying to get this thing lined up to run truly, and the dial test indicator I was using was going all over the place, and then with this falling forward, that didn't help at all. So what I ended up doing, as I say, the one that we're working on now is actually the second wheel, and I had a reasonable degree of success with the first wheel that I did, but so I was quite happy with that in a sense. But yes, I did try to be somewhat professional and set this thing to run exactly correct in the 4-jaw chuck. But as I said, I spent about 4 hours messing about trying to get this right, and in sheer desperation I thought, let me just see how accurate the 3-jaw chuck is, and see whether I can cope with the inaccuracy of that, bearing in mind it's supposedly a cheap Chinese lathe with a cheap Chinese chuck. It's not a Bernard chuck or anything like that. It's just a cheap Chinese chuck that came with the lathe. But I'm quite satisfied with the lathe, and certainly I think it's good enough for doing the tasks which I'm wanting to do on it. Now I was gifted this lathe by a friend of mine whose father owned the lathe, sadly passed away. So I'm quite impressed with the accuracy of the lathe. So having said all of that, then come across and have a look at the accuracy that this 3-jaw chuck is running at. So I've adjusted the bezel of this dial test indicator now to 0. So let's see how far out this hole is concentrically running with respect to the lathe. And if I just turn the chuck, each one of these digits is 0.5 thousandths of an inch. So that's 1 thousandths out at the moment, I think. If I set it to the worst case scenario on one particular revolution, so there we are, that's 0 now, and the dial is only going this way, the needle is only going that way, and it's going about 4 digits, so it's going about 2 thou. So I don't think for the quality of the lathe, etc., and the chuck, and the fact that it's got this insulation tape type gas tape round here protecting the teeth from this jaw damage, then I think 2000 isn't bad at all, really. So I'm quite happy to go with that, and I'm sure it'll be good enough for what we want to do with this wheel. The one that I did for the first axle isn't as nice a fit as that. Mine drops straight down actually, which I'll show you on a clip later. But even this one drops reasonably straight down, and this is the one that came with the locomotive. Now I've got to try and replicate that with this lathe on the new gear wheel. So I'll bring you in a bit closer so you can have a look at the tool that I'm using. I'll do away with the dial test indicator now, because I think that's good enough for what we want to do with this particular project. So if we just have a look at the tool formation, then we can see that this is my extreme forward tip here. So this tip here needs to be the nearest thing towards me, the operator, and then it's cut back slightly, so it's sloping away now, as in sloping that way effectively. From the tip it's sloping that way effectively. And then also if we look down here, if we look that way, we can see that again this tip here is the most forward part, and then there's relief ground onto the tool underneath here, so this is sloping back. And again, if we can have another look, maybe, I'm not sure whether it will focus, but the underside of this here, the underside of this bit here is actually rounded off in a semicircle almost, such that the tool isn't going to bind on the bottom of the hole that we're forming effectively when we try to put the tool into this hole here in the wheel. And we can see that it's slim, it's quite slim, because I need to get this part of the tool right through the 6mm wheel and out of the other side without the bore in the wheel catching on any of this shank of the tool. So I think you can perhaps just make out now that relief where it's sloping back in that sense there from the tip. This is actually the extreme cutting tip here. So we'll see how that goes. I managed with the first one with a reasonable degree of success, so I'll film this one for you, or part of it, and see how we go. But that's the tool that I'm using, and you can hopefully see how it's had to be ground away such that it doesn't foul on the bottom side of the hole, if you like, as we're forming the hole. And you can see how this tape here now is hopefully protecting the teeth from any damage. So I haven't cranked on the chuck key, I've just snugged it up really, and the idea is that it's only a plastic wheel anyway, and I'm only going to take very light cuts because I do not want this wheel to start spinning in the chuck jaws at all. So I'm only taking light cuts with the tool, and it is only plastic, so I got away with it with the first one. Let's see how we go with this. And to move the carriage here this way, I've got to be using this hand wheel here at the extreme end. That's the hand wheel, and this is the thread that pushes this carriage backwards and forwards. And this is a hand wheel, obviously, that takes the carriage across. So I'll be using this hand wheel and that hand wheel there to move this tool forward into the work and towards myself as it cuts the diameter of the hole bigger. So that's the operation. So as I said, it's not excessively tight in here because I don't want to damage the teeth, but also I'm only taking light cuts such that the wheel doesn't jam and cause the teeth to be damaged. But I think with the sort of tooth out inaccuracy of the chuck or lathe spindle, whichever it is, I think we'll get away with what they were doing on this particular task. So let's crack on. And I'll just give it a quick safety spin to make sure that everything's clear, nothing's catching the chuck jaws. And I think what I'll do, I'll extend the tool a little bit further out because I don't want the jaws, this sticking out part of the jaw, to catch on the bottom of this top slide here that's actually carrying this tool post. So bear with me while I just move this tool a little bit further forward. Check that everything's tight. So again, the width of this tool will only just fit through the hole really. So as I take a section off here, it will make the hole bigger all around, such that the tool will actually go in completely once we get working on it. So let's see how we go. Safety spin. I've just moved position there because you couldn't really see what were going on, I don't think. So let's see how we go now. just creeping up on it to the point where the tool starts to touch. I could hear it just touching there. Moving in a few thou at a time. You can see it's starting to cut the delve in now. Got a brush for reaching in there and just cleaning off the swarf, as it were, so I can actually see what's going on. So I'm looking to see that the back of the tool isn't touching the back of the hole effectively, and that the bottom of the tool isn't touching the bottom of the hole effectively. Down the side of the wheel now, from this side, and I can see that the tip of the tool is now poking through the work, so I'm going to withdraw it now this way. And it's brought the wheel with it. So now I've put the wheel back in to the jaws, pushed it hard against the face of the jaws, such that the wheel won't be wobbling effectively like that. And I've cranked up a little bit on the tension, but I don't want to put too much tension on because I don't want to damage the teeth, which is what this silver tape is all about, protecting the teeth. So let's have another go now. Safety spin, everything's clear. try retracting the tool again and see if we've made the situation any better. Yes, we got away with it that time. Put another couple of thou on the cut itself, and then bring the tool into the work again. Looking round the side again, and I can see that the tip of the tool is just about through the work now. So I'll retract the tool again. Clean the swarf off. This is no more than a brush you would use for painting behind a radiator in the house, I think. Put another couple of thou on. In fact, maybe not as much as I did. And then I'm only entering the tool very, very slowly, because I don't want it to grab and catch on and spinning the chuck itself. I was very fortunate previously that when the wheel came loose, it came away from the chuck jaws and didn't come to any harm. I'll discuss later another method I considered using, but I've opted to go with this one because this just seemed easier at the time. And of course, every time I take a little bit off this side of the wheel effectively, it makes the whole diameter of the wheel bigger, and so gives the tool more clearance all the way around. Clear of the work again. Got a little bit more of a cut on. Move the tool in again, nice and steady. So I just keep moving my head round here to look down the side, down the back side of the wheel, if you like, looking for the tool coming out. And also I'm using the hand wheel and noting whereabouts the hand wheel is in position when the tool actually comes out of the back of the work, so that I can always put the hand wheel to that position, and looking down the back I can be assured that the tool has come right through. So I'll bring you through to a different position, and then you can have a look at something from a different position. So there we are, let's see how we go. You can just see the tool starting to push out the dowel ring now as it's cutting its way through. That's the first time it's actually done that. It normally just coils up, as it were. But you can see the speed perhaps of the advancement of the tool, and I'm just going to carry on in this similar vein until such times as I can fit that where's it gone? Let me get it for you. Until I can fit the larger diameter of this button here into the hole that we're creating. And when I've got that somewhere near, I'll bring you back and we'll have another look at it. You can perhaps just make out now that the tool is right through the work and sticking out of the inside of the wheel, shall we say now. So I'll retract it again back out from the work. I'll take you off the tripod so hopefully you can see a little better what's going on. So you can see it's cutting the dowel in again, and whilst it's doing that I'm looking from under here to make sure the bottom of the tool isn't touching the hole, etc. And I've been looking from this side to ensure that the back of the tool isn't catching on the back side of the hole, which is getting increasingly bigger all the time. And then I've been coming round here looking this way such that I can see the tip of the tool coming out of the back of the wheel. That's what I've been doing, so that's what I'm going to carry on doing, and I'll bring you back when we're near a fitting of that that button that we made. So along the process I keep backing the tool out and then taking this mandrel that we made, just keep trying it to see whether it goes into the hole. And I've got some more machining to do yet, and this dial here is showing about 22 or something like that, 20. And I need to be going at about 44, I think I did the first wheel at. So I've a little bit more to do, but that's what I'd keep doing. I'm testing this I'm using this as a comparator for the bore size. So I keep trying to make it go in, and I'm just moving this tool this way and then that way to make this hole bigger, to accept that. And then once I've got it such that this fits, then I will try the proper axle in. I'll take this carriage here, by winding this handle here, I'll move the carriage far enough away from the work such that I can try this this axle in here with that's the original wheel on this particular axle. So that's what we're on with. When I get this little mandrel to fit in, I'll come back and show you then. Well, I'm still taking some out. Well, I'm still taking some out and just trying to give you a different angle as to what I'm actually doing here. So I'll just try the mandrel thingy that we made again. We're still not going in, so that's good. We've not overshot. And all the mess that was on the back side of the wheel on the inside, that dowling that was shaving off coming out of on the back side of the cogwheel, that's starting to break off now. When I'm looking down the side here, I can see that it's breaking off. But still, we haven't got this to fit in. And still we're not at the 40 some that I had the other day when I tried the first wheel, but we have moved this tool about a bit, so that it may have altered the reading on the dial gauge. But you get you get the idea of what I'm actually trying to do here. And I think you're realising now, as a novice, how long it takes to actually perform each individual task. So model engineering isn't a quick job. So you can appreciate when you see somebody's splendid model running around the track, just how much time and effort they've put into that model. And I'm keeping checking, because the last thing I want to do really is make this massively oversized. A little bit oversized we can do with, I think, but I don't want to go mad with the whole. So it's a case of checking quite regular and only taking little bits out of the board just a little time. So the mandrel then is just starting to go into the hole now, and I've only gone a little way into the hole, into the depth of the wheel, should I say, such that if I overshot, I would only overshoot over a couple of millimeters of the thickness of the wheel, as it were. but that seems all right. That's so I'll continue that cut into there to the full thickness of the wheel and see how I'll land up then. And I'll just try it through with that and see how we go. Can't be far off now. But it's still tight. I'll take just a smidgen more out of the bore diameter there.
Try that.
Again, I've just gone part way into the wheel to see what kind of a fit that is that I'm creating. So it's something of a slacker fit, but it's still tight, so we'll go a little bit further at that. The same setting will go right through the wheel. Send the cutting tool through a couple of times at that setting to take a spring cut if you like, although the tool itself won't have sprung anywhere, but the dowelling might have sprung somewhere. Well, the cutter's brought something out there, so if there's something on the tip of the tool, there must have been something come off the work. So again, I'll send it through at the same setting. We'll try that. I was possibly pulling some of that mushiness that was on the inside. I was probably pulling some of that out with me. Well, I'm going to take a bit more off the internal board of that. Just a smidgen more because it fits, but it's a tight fit. That cup of tea might have to wait a moment or two. One of my favourite sayings is you can't rush a job like this. Hey, you can't rush a job like this. I'm sending the tool through again at that same setting. And then we'll try again. When I've got this mandrel to fit, then I need to try it with the axle itself. So again, I'm just trying the original wheel on this to see what sort of sloppiness I'm actually looking for, or tolerance, should I say, what tolerance I'm looking for. That sounds posh, doesn't it? I'll take a smidgen more out on the so I'm bringing the tool towards me a little bit further, just a smidgen, going at it gently. I don't want to overshoot massively at the last moment, although I don't think it would matter all that much really, because we've already got our 3 fixing points that fix it to the wheel itself, to the back of the wheel itself. We've got the 3 holes in the wheel, which is why we put the 3 holes in first before we started to bore this out, in case we made a mess of it. And we wanted to know where those 3 holes were with relationship to the centre of the wheel. I'm going to take a smidgen more on the diameter of that bore. I'll run the tool through again at the same setting now. And I'll run it through again at that same setting. So it's had a few spring cuts at that now. See how we go. Well, it's still tight, as we can see. So I'll take a smidgen more, a 1,000th at a time, something like that. See how we go. You can see how sort of sticky grabby this stuff is. Now it's just, so that might be fooling me on the diameter of that hole, that bore. So we're just going steady away with it. I still can't push it in far enough to get the wheel face up to the face of the shoulder here. So we need more to come out. I think I'll have earned that cup of tea when I get it. Well, it's fully in now. It has got a degree of waggle to it, but still not as much waggle as this one has. So I don't think that would go down the axle yet, or it goes onto this mandrel. So perhaps it's worth having a go. So I'll try the axle on there now. So I've moved the carriage now as far away as I can, such that I can try and get this axle onto that shaft, onto there, and there it fits. So I'm glad I didn't decide to take any more out. It does actually fit on there. So it's a reasonable fit on there. Now I'm sure that will do me. That's the original fit of the original wheel. So I'll take this one out of the chuck now. Hopefully we've not done any damage to the teeth, and hopefully that will kind of wobble down the length of the axle like that one does. And if it does, we'll call it a do and we can go and have a cup of tea. It's out and we can see the sort of mess that it made as it, that's what was on the back face of the wheel, if you like, as it was pushing it through. So I'll just clean that off with a bit of emery cloth or something, that mess there, or like a reaming or a countersinking tool, perhaps, just to take off the burrs around there. But hey, let's have a look, see how we've done. So it's perhaps a better fit on the wheel than the original. A better fit on the axle, sorry, than the original wheel. I'll just run my little deburring tool around there. And round there. Just to take off the edge. There we are, that's better. And then I'm going to have this part of the wheel facing such that anybody who takes a locomotive out of service can actually read it without having to take the wheel off to see it. So there we are. I think I will call that a runner. So these are the bolts that will hold it to the back of the wheel, and we can see the black mark that I put on the wheel and the black mark that I put on the inside of this flange of the wheel. There's a flange of the wheel, and that's the black mark that will relate to. So this one will pick up on there, etc. I think it's all self-explanatory, that then. So yes, I think I'm quite happy with that. Thank goodness. Let's go and have a cup of tea. 2 down, 2 to go. But I won't bore you with the other 2, at least you know the crack now. You've seen what I'm working on, so... And now I'm creeping up on it so I don't overshoot. Right, I'm heading for a cup of tea. I will catch up with you all later. And while we're still on the subject of the motors and the wheels, etc., and removing the wheels from the set such that we can work on them, let's just have a recap of what I've been finding with the motors. Number one motor, it was just a case of undoing the grub screw and literally pulling the wheel off, because the wheel was actually loose on the axle to start with, and the only thing keying it to the axle was this grub screw here. And on motor number 2, when I undid the grub screw here, I still found I couldn't get the wheel off, but the wheel was tight on this axle shaft. So what I did there, I got the soft face hammer and I tipped the motor up such that the end of the axle shaft was on the wood, and so the axle now won't move. And then I tried to drift the wheel off the axle with the soft face hammer, just going up round like that, and that's how it came off like that. Now on this particular occasion, number 3, that's a miracle that's come off, because it didn't come off last night when I tried that. To which end I went downtown and bought an appropriate tool that I spoke about before, but having misplaced, and I don't know where it is even to this day. But I went down in preparation of getting this one off, which has just now fallen off when I tapped it, but last night it wouldn't. And so this is what I bought, which is what I was previously talking about in the video, a gear puller. I couldn't find mine, so I've been down and bought this one from the second-hand market, because you can get good tools at the second-hand market, probably a better quality tool than you could buy for the same price brand new in today's modern automotive shops, or certainly some of them. And the way these work, you literally clamp around the back of the wheel effectively. This one's clamping in 3 places around the perimeter of the wheel, and then I'm screwing this screw here, and that's drawing this nut here up the length of this thread, and down in the bottom of this thread here I've got the end of this shaft is actually inside, just resting on the end of the axle there, and so it's effectively pulling the wheel now off the axle by pressing on the axle as these come back, and that's what's happening over here. But I'll show it you in any event, because some people may not have seen or heard of these before. Now if you've got somebody to help you hold things and align things, that's brilliant. Quite often you don't have, so it's a bit of a struggle. But that wheel should come off now, and I'm using a 19mm spanner to crank down on this, and that will pull this nut and these levers and these grabbing arms up, using the centre of the axle as a pressure point to force itself up. I'm not sure if you can see that wheel moving now, but these claws, the 3 claws, are actually pulling the wheel now off the axle shaft. I'll just move position of the camera so you can have a look. Hopefully now you can see what's going on. As I turn the screwed thread, it's winding this up the length of the thread and pulling these jaws with it, and hence pulling the wheel against the centre of the axle. So we can actually see there what's happening there. Then you can remove the clamp and just take the wheel off. So there we are, and this this screwed rod here has a pointer in the end which locates in a centre in the axle or the end of the motor shaft if you're trying to pull a cogwheel off a motor shaft. And here then we can see the position in the axle shaft itself, which has been milled. It's had a milling cutter run across there such that when this grub screw bites down onto that milled flat, it doesn't actually cause the roundness. If I just turn that round, it doesn't actually cause the roundness of this to become damaged, but it looks as if it slipped or something, and somebody's realigned it here. So it's been realigned at some point on that point there. So this is the only thing that's stopping the wheel from spinning loose on the axle. So when I reassemble these, I'm going to put some Loctite on these threads such that they don't work out and allow the wheel to just spin. So that's part way out and it starts to spin, it will gnarl up the shaft of the motor, and next time you come to remove your wheel, you're going to have extreme difficulty getting it off. Like last night, I couldn't tap this off with my hammer, so I went and in the absence of not knowing where my other one is, I purchased another one of these, which is absolutely brilliant because this one's quite an elaborate one looking at it. It's got two different positions. Well, I can fasten that into there, or I can move this across to here, and I can reverse the jaws and use these jaws instead of the longer jaws. So it's quite a versatile piece of kit, this one, and for a tenner, thank you very much. So there we are. Hope that just allows people to see a little bit more about what's going on with these wheels and the issues I've had, and the tools I've perhaps had to use to get them off. And if you're like me, you can never find an Allen key. There's always one missing from the set, and it's always the one that you want. Hence I've purchased a brand new set because I couldn't find one of these I couldn't find my Imperial set, which this is. So I thought, well, it's just easier and quicker to buy another Allen key set, and this time I won't lose them out of it. I'll keep them in. When I finish with them, I'll put them back so I know exactly where it is for next time. That's my thoughts anyway. So there we are, a little bit nearer, just a little more information about these wheel sets and how they're made up. While we're on with it, here's a number. This is the motor that I took up to my friends and we resoldered those cables on, if you recall, and we can see that whilst I've been knocking that off, this motor has actually drifted down the length of the motor axle, and so it's only half engaged with the plastic gear wheel now, and it should be on there like that. And the washers that we've been looking at, which are behind these wheels, between the back of the wheel and the plastic wheel, are to allow that bit of space there, so it's a little bit of running space for any movement of that. And if we watch this one come round, we'll see here there's some damage on that particular gear wheel, which is why I'm replacing them, and this isn't the worst. So that's why I'm replacing these plastic gear wheels. Okay, thanks for watching. Bye for now.